Okay. So what is this? Is this 1.1.5? I think. Okay. Or yeah, sorry. That's 1.1. I'm thinking engineering stuff. So yeah, so this is 1.5. See if I can find my pen. Okay. Well then we'll go through some of these. We won't get through all of them, but we'll go through some of these at least. So a diver at Acapulco dives from a cliff that is 61 meters high. So oh, did y'all not want to do number 2? Oh, okay. Okay. So okay, number 4. A pitched ball is hit by a batter at a 45-degree angle. It just clears the outfield fence 98 meters away. Find the velocity of the ball when it left the lot. Is that what it says? The bat. Sorry, I can't read from here. Assume the fence is the same height as the pitch. That's a good thing. So at least we don't have to worry about that extra height at the end. So we have a ball that gets launched. The angle is 45 degrees and it's going to go through this nice little parabolic trajectory and then reach on the other side. They gave us the range, how far away the ball went this direction in terms of the horizontal distance. So that's 98 meters for the horizontal distance. Um, so we have that. And does it give us any other pieces of information? I think that's it, isn't it? Okay. There are a couple of things that we do know. We know that since the ball is at 45 degrees, that 45 degrees complement is itself. So 45 plus 45 would be 90. So the vertical and the horizontal velocity should be the same. So then we can add those together. Um, that's helpful. But let's see, 98 meters and the find the velocity of the ball. So if it covers this range, what do we need? How about we write out our DVAT first? Think DVAT's a good idea? What's up? Yeah, we can use the range formula if you want to. Do we have the range formula? It's not on the equation sheet, but the range formula is available. Okay, VI sine 2 theta over G. Is that it? VI squared. Thank you, thank you. Yeah, there is a squared there. So from the Googles, we learned that the range formula for something. Now that VI, what kind of velocity is that? Is that the x direction, the y direction, or just the total velocity? Uh-oh. Well, so yeah, so we have the range and we have the angle, right? So this looks like a perfect equation to use because that gives us both the r and the theta. So the VI that it's speaking of here is actually the total velocity. So instead of thinking about it in the x direction or the y direction, the VI is the actual velocity that's going up at a 45-degree angle. So there is a VI x direction, there is a VI y direction, and this VI in the formula, that's this one right here, which just happens to be um, what we're looking for, right? Yeah, find the velocity of the ball when it left the lot. So we can make our whole life easier and just do that. So 98 meters is equal to VI squared sine of 2 times 45. So I guess we'll just go ahead and put 90 there because that's 45 times 2. It is. So the sine of 90 degrees, when you plug it in the calculator, that's 1. And that's going to be, that makes sense because 45 degrees gives you the maximum range. And the sine of 90 degrees is going to give you 1, which is as high as the sine or cosine can go. And then we're going to divide it by 9.8. So this is 1. So I can just go ahead and get rid of this. I'm just going to write 1 there. That doesn't matter. Um, 98 times 9.8 times 9.8 divided by, oh, no, and then we're going to take the square root of it, right? Equals VI squared. So VI is going to equal whatever the heck the square root of 98 times 9.8, which comes out to be what? 30.99? Okay. Well, that's it. 30.99 meters per second, or basically 31 meters per second. That's going to be our answer for that one using the range formula. I kind of like halfway feel like we cheated on that one, but that formula is fair game. So if that's all that they're asking for, then yeah, that one is not on the AP Physics formula sheet. It is useful to know, but it's not on the formula sheet. And it deriving the range equation is not for the faint of heart. It does, since there is a 2 theta here, it does require trigonometry to go from the kinematic equations to the range formula. So in this case, I would actually say it's easier to just remember the formula than it is to figure out where it came from. I'm sure there's college professors hissing at me currently right now for saying that, but that's okay. Yeah, they're like, no, you need to derive. Like, whatever, it's okay. Even for AP Physics, it's okay. Um, questions? If we needed any other variables, we would have to use the dvat, but since it was just asking for the velocity, we can just use that formula and get away with it. Okay? Correct, yeah. So like our dvat becomes a lot easier now that we know what the velocity is. Absolutely. Because if we didn't, we would have had to have broken down a lot more stuff in order to get it to work. Um, yeah, we know that it went 98 meters, and that's a distance over time. We would have had to have used substitution in 2 equations to be able to solve for it. Does everybody have this before I get rid of it? Yeah, if you did it and you still got 31, that is absolutely great. Yeah, but it will be a 2 equation, 2 unknown system. Okay. And that goes to show you there is more than one way to do things. Well, let's try one. What is it? Number 5. Okay. Basketball player tries to make a half-court jump shot, releasing the ball from a height of the basket. Oh, we're really at the height of the basket? Okay, so they're jumping really high. Yeah, he's really tall. Assuming that the ball is launched at 51 degrees, 14 meters from the basket, what velocity must the player give? Guys, that's the same one as last time. So can we just say use the formula that we just did on the last one and you're good to go? It's the exact same thing. So just try that one. Well, let's find out. Let's look at number 6 and you tell me. Is it going to be the exact same process? But you can know it. Like, how would you know if it's the same thing or not? If you have a Well, I'm looking at number I'm looking at number 4. Number 4 has an angle, and number 4 had a range, right? So if I had an angle and a range, I can use the range formula. Okay. Number 5 also has a range and an angle. Number 6 does not. It says that it's 75 meters tall. That's not a range. So the range formula won't work for height. The range will only work in the x direction. So number 6 cannot be solved with the range formula immediately. So how far it is from the base of the cliff does the ball land? We're going to have to use at least something else first in order to get that. So do you want to do that one or number 6 breaks your brain? Okay, that means that that's probably one that we want to do. Uh, so let's see here. The top of a cliff, which is 75 meters tall. So I'm going to draw a little cliff. I probably actually need to draw this higher up because something tells me I'm going to need a little bit of room to work. So here's the cannon at the very beginning, and it's 75 meters high, and then it's going to get shot off like this. Okay, because it's 51 degrees. So there's a velocity to start with, and that angle is 51 degrees. Okay, and let's see, 125 meters per second. So 125 meters per second. Okay, and then it says how far are we going to get this to go? So there's a range, and we need to find out what this range is, this delta x. So you want to call it x, you want to call it r, what do you want to call it? Distance, d? I mean, either way. I normally call the x direction the distance, and I normally call the y direction the height. So you have d going left and right, and you have h going up and down. You could use X and Y, and it doesn't really make a difference. Um, so let's write out our DVAT. So remember, in order to do a projectile problem, we need to split up our DVAT into the X and the Y in order to actually do this. So I'm going to split it apart. And for the X, the only thing that I need is distance, time, and velocity in the X direction. Because my acceleration in the X direction is 0 meters per second. Okay, squared. And that's all I really need. The VI and the VF are the same, so do we have the displacement? D. Do we have the time? T? No, we don't know the time. Do we know the initial x velocity? Can we find the initial x velocity? How? Okay. Yeah, so we got 125. So we got 125, and then the x direction and the y direction. If this is 51 degrees, then this is going to be 125 cosine of 51, which gives us a number. 78. I'm going to believe you on that. Do I get a second on that? It seems reasonable. 78.6 meters per second for the cosine. We're doing 6, yeah. Doo dee doo. And then on the other side, we're going to do our DVAT. So VI, VF, A, T. What is my distance in the y direction? We're going down, so it's 75 meters high, so it's negative 75 meters. Okay, I can go with that. I didn't write that in the problem. That's my problem. 75 meters. There we go. VIY? Okay, and that's using the sine, right? So this would be 125 sine of 51. Okay, so it's 125 sine 51. If it's in the y direction, it's going to be the sine. If it's in the x direction, it's going to be the cosine. Or if it's in the x direction of the line of action, so it doesn't have to literally be like x and y. When we get to forces later on, we're gonna use the line of action, and sine and cosine can be at like weird angles stuff too. But anyway, what's the VFY? I don't know. So we're gonna put a question mark there. What is A? Negative 9.8 meters per second squared. What is time? We don't know. Okay. We don't know yet. We don't know yet. Okay. Right. Um, so we have a couple of pieces of information, and where would y'all like to go with this? Well, what are we ultimately we're trying to find the range, yeah. If we had the time, we could just use velocity equals distance over time for the x direction because we know that things going in a projectile travel in a constant speed. So can we use the y equation to find the time? Which one do we need to use? Yes, that's not an equation. Yes isn't an equation. The one without VF. Okay, yeah, because we don't have that one, right? So distance equals VIT plus 1/2 AT squared. We don't have, we have all those numbers, right? So I think we're okay. Um, okay, so the displacement is negative 75. And your VI is 90. Oh, I actually literally wrote 125 sine of 51. I'm a terrible person. I'm sorry. What was that? 90 something? 97.1? Meters per second? Okay. That was, yeah, sorry. 97.1 times time. Was that a positive or a negative number? Okay, because it's going up, right? Good. Okay, 1/2, negative 9.8, and then times t squared. Okay, this is a quadratic. Ooh, like part of me, part of me says that there might have been an easier way to do this, and the other part of me says, well, we're here, so we might as well. There might not have been. It might have been just it. So the first thing we need to do is get everything to the left side so that you have 0 equals what's half of 9.8? Is that 4.9? So it's negative 4.9 t squared. It's usually easier to write it like your math teachers taught it to you. Plus 97.1 times time plus 75. And that's a proper quadratic right there. We can use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. We definitely did this to ourselves. Yeah. So you'll get two answers. You'll get a positive answer and you'll get a negative answer. So we're gonna do this. We're gonna do this. So let's see. Try this. X equals negative b, and the b is gonna be. I'm gonna go ahead and highlight these. This is A. This is B. This is C. So it's negative 97.1 plus or minus the square root of 97.1 squared minus 4.9, 75 all over 2 times negative 4.9. Well, that's gross. Do the negative one? Okay, so the minus. Because the positive one gave you a weird 20 seconds. So I guess I need to go ahead and erase these x's, and we're really good looking for t. So t is about 20 point what? Did it come out 20 on the dot? 20.6 seconds. I didn't figure that it would. This doesn't seem like it was going to be one of those like, oh, hey, this comes out perfectly fine. I need somebody else to get 20.6. It worked. Okay. Okay, so we have two answers for 20.6 for running through negative 97.1 minus the square root of 97.1 squared minus 4 times negative 4.9 times 75, and then divided by 2 times negative 4.9. All right, so at least we got a time now. Let's put that in our DVAT. And well, hang on. Does 20.6 seconds make sense first? Let's think about it physically. Does it actually physically make sense? Right. So you had to go up and then down, and also you're standing on top of a 75-meter cliff. To put that in reference, the school's height is probably up to the second story, somewhere around 10 meters. So you're going like way up there. 20 seconds from was shooting something up. This makes sense. This is reasonable. It's reasonable. Um, yeah. What is our So you found the distance straight from that? I guess you can, because we have the velocity. And if we have the time now, it's just distance over time for the horizontal speed. So we're going to go 20.6 seconds. And then our velocity, 78.6 meters per second, is equal to some distance over 20.6 seconds. Okay? And that comes out to be a horizontal range of 6 1,621 meters. You're telling me this thing shot 1.6 kilometers? 1.6 kilometers? You got what? Okay, so 1619, 1621. Either way, either one of those is fine, because if you're going that far, that's within the measurement of error, definitely. Is this a reasonable answer though? 75 meters, or sorry, 125 meters per second is going about 250 miles per hour. So yeah, if you're going 250 miles per hour for 20 seconds, you'll easily cover a kilometer. So that's reasonable to me. That's totally reasonable. Okay, so 19, 16, 19, 16, 21, whatever, that works out. Does anybody else? That's okay. Yeah, and if it rounds a little bit, that's fine. Can I erase this? Are y'all still working on it? Okay, that's a good one to have for an example. Yeah. All right. There it goes. Bye bye. I'm glad that I don't have to like. I'm glad that it erases like a word at a time, and you don't have to erase like all of the pixels. Okay, so that was a good one. What's next? Is that an object projected at an angle of 30? Yeah, it does reset because I just basically pull these from everywhere. So this one says that it gives you an answer 441 feet. I don't like feet, so I'm probably gonna just change that over to meters unless y'all are. You've already put it in feet. Okay, well okay, if you're already in feet, we'll go. We'll stick with feet. That's okay. Everybody in. Yeah, that's an engineering thing. Okay. I think I guess I'll stick with it in feet. I guess that's okay. Um, an object projected upward at an angle of 30 degrees has an initial speed of 128 feet per second. How many seconds will it reach the ground? How far from the point of projection will it strike? And find the angle if it strikes the ground using the arctan. So basically, that's just using trigonometry. I know, like y'all see arctan and y'all start freaking out, and you're like, "Oh no!" But it's not that bad. It's really not. It is because it's symmetric, right? So if you did the problem right, when you find the answer at the end, it should come out to 30 degrees. Because if it's 30 degrees going up, it should be 30 degrees going down. Why? Oh, well, I mean, like, arctan is just the angle whose tangent is. So whenever that's how I always remember it because there's an arc sine, an arc cosine, and an arc tangent. But since it starts with an A, I just remember it as angle whose tangent is that thing. So if you're making the triangle, then you're just going to use the tangent and then use the tangent to the -1 button on your calculator. Y'all, I think y'all have used that before. I mean, like it's not new, right? Oh man. Oh man. Oh man. uh, you're right. You're right. Last year was extreme times. Oh. Well, it is what it is. So I guess you're right. So we'll do this parabola. We're making this trajectory path. And we know that it's traveling at 128 feet per second. Is that right? 128 feet per second. Okay. And what else did it give us? Is that it? I think so. Okay, we're looking for time. So we have the speed and we have the degree. If you have the speed and the degree, you can use the range formula. That's true. Yeah, that's true. So do y'all want to use the range formula or do you want to DVAT? Smart. Smart. So the range, which is going to be the distance this direction, is going to be vi squared sine 2 theta over g, and we have all those. The vi is 128. Just remember our answer is going to be in feet, not meters. So it's 128 squared times the sine of 2 times 30, 60 degrees, divided by 9.8. That gives us the distance. I'll need a number and then a second. 44, 47? Okay. 44, 47 feet. But keep in mind that 44, 47 feet isn't a total mile. Oh, that's our problem. Yeah. I see. I told you I should have changed it over to meters. You're right. G is in feet. It's 32 feet per second. You're right. You're right. You're totally right. You're totally right. Yeah. Okay. So now what do we get? Yeah. 440.6 feet is equal to the distance, right? Okay. So we now have the horizontal distance. We can use that information to find, because I think it just asks for the time. How many seconds will it take to reach the ground? So instead of having to use our DVAT, if you know how to use horizontal motion, it might help to just write out DVAT anyway. X direction, Y direction. Like, I would say always write out DVAT. I don't know, y'all might not agree with me, but I would say always write it out, especially if y'all have issues knowing what to do with stuff. So, distance, VIX, VFX, A, and T. And if it's in the X direction, I know that my acceleration is 0. And I know that both of these are going to be the same. So our distance came out to be 440.6. And then over here, we'll have a distance VIY, VFY. And I guess I better call that dx and dy so that y'all don't get confused. Acceleration and t. The acceleration in the y direction is always negative 9.8. Oh, crap. Negative 32 feet per second squared. Feet per second squared. You can tell I'm so trained in meters in physics class that it's, yeah. Yeah, feet per second is a number that we're not necessarily used to. Okay, so if you look at that, we can figure out what we need from the x side, because I think we have a feet per second as well too, but I can't use 128 because that's the total speed in the x and y direction together. So instead, I need it's not going to be the sine, it's going to be the cosine. Cosine is the x direction. Okay, so make a triangle. Whoop. This is 128. Okay, so 128 cosine of 30 degrees. That's going to give us our VF, VI and VFX. Doesn't change. 110.8 feet per second. Okay, that's reasonable. That makes sense to me. It's below 45 degrees, so you're going to have more feet per second in this direction than you're going to have in the y direction, and that works for me. What would the speed be in the y direction? What's 128 sine of 64? 64 feet per second? Okay. I ask because I want you guys to actually try this in the calculator without like blowing yourselves up. Because it should work. If you type in the tan negative 1 of the y over the x, you should get 30. You should get 30 degrees. So you just type in 64 divided by 110, and then you tan negative 1. So in your calculator, it'll look like this, tan negative 1 of 64 over 110 110.8. And if you did that right, it should come out to be 30 degrees. That's what they're just wanting you to verify. Like, did you get your velocities correct? So you can work backwards and find that angle. So how far? No, no, no. How many seconds will it take to reach the ground? Exactly. So since there's no acceleration there, we could just do velocity equals distance over time, and these will actually work out pretty well. You're solving for time, right? So flip-flop those variables, and its time is equal to distance over velocity. So the distance is 440, the velocity is 110. That comes out to be um, no, no, no way. That's completely unrealistic. How are you getting 48,000 seconds? That doesn't work. The distance is look, time is equal to distance over velocity, right? So like just looking at that, if you type in, "Hey, my distance is 440. Hey, this is 110." Dude, that is not going to be 48,000. 3.98. That makes a lot more sense to me. That makes a lot more sense to me. 3.98 seconds. There we go. So that gives us our part A, our part B, and our part C. Okay. How long did it take to reach the ground? 3.98 seconds. How far will it be? Using the range formula, it was 440.6. And then the angle was 30 degrees. You didn't have to do the arc tangent if you know that it's hitting the ground at the same height from which it began. It's going to be hitting the ground at the same angle. 30 degrees going up, 30 degrees going down. Uh, that is obviously assuming no friction, which is just how we do. Um, okay, and I think we still have a little bit of time left. We got about 10 minutes. Do y'all want to do another one, or are y'all okay? Okay. Let me erase then. Ooh, the yes, yes, break them. And keep in mind this is for the digital kids too, so rip virtual students. Uh, okay, so we wanna try number three. Okay, let me go down. Let's go down and look at it. Number three, a projectile is fired upward from the top edge of a vertical 200-meter cliff above a valley. Its initial velocity is 60 meters per second, 60 degrees above the horizontal. Calculate the distance from the base of the cliff to the impact point on the valley floor. Okay. So picture time? I think it's picture time, right? Picture time. And good news, the answer is there. It's the answer is what, 408 meters. So I mean, you could just be like, here it is. We're good. You're just gonna chill. Okay. Well, that's the point of actually doing your homework is that if you did it and you've already traumatized yourself, you don't have to do it again. Vertical 200-meter cliff. So this is 200, right? You don't get homework in an AP class. Enjoy your AP score. I mean, you should get at least some. You should get some homework in an AP class. What else do we have? We have a vertical height. We have yeah, we got that. 200 meters. What's the speed? It's sort of like flat out 60. Okay. 60 degrees from the horizontal. So this angle is 60 degrees. Okay. And we need to calculate the distance from the base of the cliff to the impact point on the valley floor. So we're looking for this distance right here. Okay, and I don't think we can use the range formula because the range formula assumes that you're starting and ending at the same location. So the range formula won't work this time. We can't do that. So I think in this case we have to do our DVAT in order to make this actually work out. But first of all, before we do our DVAT, let's take our 60 meters per second and let's break it apart into its components. I know I'm going to have to do that. So 60, oops, I actually hit the click. There we go, 60. Um, my triangle, this is going to be 60 cosine 60. Uh, I think they did that on purpose. Like everything is 60. I feel very confused. The vertical one is going to be 60 sine of 60, and thank goodness those actually turn into different numbers. So in the x direction, 60 sine of 60 comes out to be 51.96. Can we do 52? Is that okay? Oh, that's sine? Okay. Whoop. So 52 meters per second. Okay, what about 60 cosine 60? 30 meters per second. So I'm going to put 30 meters per second. We're going to need both of those. So let's go ahead and write out our DVAT. X, Y, down the middle. DVAT, D, VI, VF, A, T. D, VI, VF, A, T. I figure if I do this enough with you guys, you'll actually remember it. We've only, we've only, I had a physics professor that would always say, "You've done this 100 times." I figure at this point we've done it about 20. So, we need to do it 80 more times before it commits to your brain and just scars in there for the rest of your life. He was Chinese, so he was from China, and he was very, he assumed that we knew a lot of stuff that we didn't know. So, yeah, he's like, yeah, clearly you're supposed to be here for a reason, so and we're like, oh no. Okay, D, what do we got? Oh, okay, we don't know. VIVF. Ah, we do have that one. Both of these are 30. 30 meters per second. Acceleration. Time. We don't know. Okay. Yes means I know. Yeah, you don't want to say yes. I don't know. Or no. Distance in the y direction. Are you sure? Negative 200. It is not the same thing. Direction matters. Direction matters. VI? Positive or negative? Positive 52 meters per second. Okay, that's reasonable. VF? No. Do not know. Negative 52, like if you said negative 52, that's going to correspond to you right here. So the the VF, if you went just this distance, is going to be positive 52 here, negative 52 here. So it's going to be greater than negative 52, but I do not know what it is. So I'm going to put a question mark. Okay. Acceleration, negative 9.8 meters per second squared. Meters per second squared. And the time? We don't know. All right. So we need to, we're looking for the range, right? Which means what we really want to find is we want to find the time. So I need a kinematic equation that solves for time without hurting me. We have to do the quadratic again. We have to do the quadratic. There's no other choice. Displacement equals VI t plus 1/2 a t squared. Okay. So we know the distance is negative 200, and that's equal to 52 times time plus 1/2 negative 9.8 times time squared. Okay, so we have an A, B, and C. So remember the A is going to be with the t squared, so I'm going to move that. Negative 4.9 t squared plus 52 t Plus 200 equals 0. That's going to move that into a standard quadratic form. So A, B, C, and then we quadratic formula it. And then the trauma commences, which it's really not that bad. If I liked y'all, I'd teach you how to plug it into your TI calculators. But actually, a lot of people just use cell phones for calculators now. But yeah, you'd have to program it to do that. But or you could download it off the internet because they've made programs that'll actually solve it. It just says like input A, input B, input C, and then it'll actually give you the letters. Um, so T equals -52 plus or minus square root 52 squared minus 4 -4.9 200 all over 2 times -4.9. Okay, that's gonna give us something. So you're gonna get two answers, and one of them won't make sense. Right. So if you get a negative time, you 13.6 seconds. 13.6 seconds. Do I get a second on that seconds? 13.6 seconds. I like how I said 13.6 and wrote 13.2. There we go. 13.6 seconds. Is everybody okay with that? Okay. Well, let's double check because I think, doesn't this give us an answer? Doesn't it tell us what the answer is? Or does this one not give us an answer? Okay. Well, if it said 14, we're pretty close, considering I just rounded a lot. So, yeah, I think we are. I had to scroll down, but yeah, you're like, scroll up, scroll up, scroll up. What's it say? 408 meters. Well, we're not done yet. We still have to go. We found the time. Now we need to find the distance. Okay, so we know that it's horizontal, right? So in our DVAT, we know that this is 13.6 seconds, and this is in the x direction. And time is also the same over here, so I'm just going to go ahead and fill that in just to be a completionist. 13.6 seconds. And so in the x direction, since there's no acceleration, that means that we can use velocity equals distance over time. We know that time is 13.6, and we know that velocity is 30. So we just do 13.6 times 30, and that equals 408. 408 meters equals displacement. Okay. So I think we only have about 4 minutes left. So I hope that this homework review was enough to make you guys not completely lost. I would really like those to be turned in so I can grade them at some point in time. That would be fantastic. So, and digital students, you too. I would also like those turned in as soon as possible.